Hey, good morning, guys. Welcome back to another video. Today, we're going to be learning about population dynamics, which are kind of the things that cause populations to change over time, whether that be to grow or to decline. All right. When we're going through this, make sure you're taking notes. Some of the topics that we'll be covering in this lesson are death rate and immigration. You may have heard this in humanities: death rate, birth rate in immigration, death rate in immigration, population growth, and then a term called carrying capacity, which you may have remembered from our vocabulary session at the beginning of the year. Um, Please record all of these in your Cornell notes in your notebook, as these are going to be some pretty important phrases for later on. So, first up, we have birth rate and immigration. Birth rate being the number of organisms introduced into a population during a period of time. For example, if I say that 5 organisms are born every month, bam, you have the number of organisms and you have a period of time, that would be a birth rate. You could say 150 organisms per year. That is a number of organisms in a period of time. That is a birth rate. Now, this is in general going to be one specific ecosystem, one area, not usually going to talk about globally, but you can say in the state of California, um, this number of organisms are born every month, and that'll generally be the birth rate. Now, immigration would be when organisms from a particular species move into a population. So a wolf that is from Washington uh, moving into the wolf population of Nevada, right? So he's walked all the way from Washington to Nevada. And usually this occurs if their current environment isn't ideal, or it has too much competition or too many individuals there. It will leave that environment in hopes of having a better chance of survival, and it'll go somewhere else where there's less competition or better resources. And this is immigration. So you move from one area into another population in hopes of having a better chance of survival. All right. Now, reasons for increases in birth rate could be an increase in the available resources, like there's more food available or there's more space. A decrease of the number of predators. Maybe the predators that were eating the individuals in that population were killed off. And so now more organisms can be born because there's less things that are trying to kill them. Yeah. Um, and also just the general lack of illness. Illness does occur, but if it doesn't occur, then the birth rates can continue to climb. And then also positive environmental change. And what I mean by positive change would be, say, like if there was a very strong rainy period where it rained very heavily for like months at a time, which is something that does happen in Australia and Africa. During those times, plants will grow more, the rivers will increase in size, and so there will be more food available. There will be the rivers and streams to be much more robust, and so a lot more organisms can then take that opportunity to breed and continue to thrive in that area without the risk of dying from lack of water. So positive environmental change, big component as well. Now, population has different types of growth. Not every growth is going to be the same. And usually this is going to be based on the number of available resources. Even if we look at human beings in general, our population has grown pretty much nonstop, really. What's called exponential growth, where the more individuals in our population, we have continued to grow at an even faster rate, just due because we just have so many resources available to us. But not all organisms have this type of growth. So we're going to pinpoint the two different types of growth and what they are. All right. So first up, we have logistical growth. Now this is where most organisms fall. Logistical growth is a very slow growth that has kind of these ebbs and flows, and it's going to be based on limited resources. So there's not an endless supply of food. There's not an endless supply of space for you to take over. There's not just nonstop resources for your population to use. And so you kind of grow, and then as soon as you get close to this line here, you see the population start to tail off or dip down. This line is known as the carrying capacity, or the limit, the absolute limit for that population. Now, it's possible for the population to temporarily go above the line, but as soon as you do, you'll have individuals starting to starve, individuals starting to struggle in their environment, and of course, that'll result in a mass dying. So the population will very quickly die right down below that line again. Most populations tend to hover around this line somewhere close to it. If they fall too low, over time they'll just grow right back to the line because that is their limit, and they tend to stay around the limit. They don't have to be too far away from it. But the other type is known as exponential growth. So that was logistical growth based on the logistics or the resources. Exponential growth is the type of growth that is experienced when there's unlimited resources. So something very similar to how human growth has been. Uh, this happens the larger the population gets, the faster it grows because there's more organisms that are able to breed. And because of the lack of, or the lack of a lack, the unlimited resources, really, this continues to go up and up and up, and it'll just start climbing basically straight up vertically as there is no limit. It'll never actually have a slowing period because the resources are nonstop and there are no limiters placed on that population's growth. So that's known as exponential, meaning the larger the population is, the faster it grows. Logistical, it slows down as it reaches a carrying capacity. So I've used that word a few times, carrying capacity. So let's actually learn what that is. So carrying capacity is the number of organisms that an environment can support without starting to break down or degrade or start to basically get ruined, right? And these resources that we're talking about when we say resources are going to be the amount of food in the area, the amount of living space, the predator count, the amount of mates, and then competition from other organisms. So other organisms that want to also use those resources, use the same food, use the same living space. So here in this drawing, we can see this fish tank clearly above carrying capacity, and we can see that some of these fish are starting to die off. In the other tank, they have plenty of space and they look good and healthy, and so they are actually below carrying capacity. So most organisms want to stay below carrying capacity because they can live nice, peaceful. Everyone gets their own share, no struggles. If you're above carrying capacity, that competition starts to kill organisms off. All right. Next up, we have death rate and emigration. So death rate is the opposite of birth rate. It's the number of organisms killed from a population during a period of time. So 5 organisms killed every 5 months or something like that, organism number, amount of time. And then emigration is organisms moving out of a population. And generally, this is going to be because the population either has too much competition or the environment is just poorly suited to their survival. So they just choose to leave in order for a better hope of survival. Now, reasons for death rate being increased, it could be a lack of resources, an increase in the number of predators, illness that is spread in the area, negative environmental change, such as a drought or a lack of water, or forest fires could be another reason. And then human interference, such as us placing buildings, tearing down forests for farms, pollution, hunting, poaching, killing animals just for fun. Those are examples of how humans could also cause death rate increases. So if birth rate is greater than death rate, then the population will increase. If birth rate is less than death rate, so death rate is greater, then the population in general will decrease. And so you can kind of keep that in mind. Birth rate is less than death rate, that population is going to fall. Right. Now, the results of a high death rate are pretty staggering. Now, if you have a very, very high death rate, the species will be considered struggling within that environment, and they'll be known as an endangered species. So they're at risk. They may not survive. This is known as endangered. This is when the population falls to very, very few. They're known as an endangered species. And then if that species has completely failed to live in that population or in that ecosystem, they are known as an extinct, which means they are no longer there. Now, you can have local extinction, which means in the state of Nevada, there are no more wolves, right? That's a local extinction. And then you can have general extinction, which means the species itself is dead and it's gone. So generally, Localized extinction occurs more frequently as organisms are pushed out of their environment by other organisms or through competition. But there's also that general extinction where whole species do die off. And this is actually a very common thing throughout the history of the planet. So it is a big deal, but it is something that is common and happens frequently. Okay. And that's the end of our video. So I hope you guys enjoyed. I hope you guys took notes. See you next time. Bye.